Hi, my name is Rachel Weiss, and this is my presentation on the effects of microplastics on the algae Raphidocelis subcapitata, which is a freshwater green algae that's often used in toxicity testing. So we studied microplastics, which are plastic particles that are less than 5 millimeters in diameter. They are a really common cause for concern these days because of plastic pollution being such a big deal. Microplastics are both manufactured for products like cosmetics and pharmaceuticals, and they're also formed from larger plastic particles that can be degraded in the environment. The effects of microplastics in particular on freshwater ecosystems is largely unknown. So we are addressing that by talking about or testing the effects of microplastics on freshwater microalgae, so our Raphidocelis subcapitata. It is a primary producer, so it's a very important source of oxygen, and it's also a vital source of nutrients for the freshwater ecosystems in which it lives. So the goal of this study in particular, over here in my objective section, was to examine the relationship between polystyrene MPs. And before we keep going with that, polystyrene is a common type of plastic. It's mostly known as the main component of styrofoam, but it has many other applications. The relationship between polystyrene microplastic pollution and algal population growth, as well as photosynthetic activity over a 7-day period. The flasks were maintained at 23 degrees Celsius in an incubator. Everything was disinfected before beginning the experiment so that we knew just the algae, the plastics, and some essential nutrients were involved in this reaction, and there were no other bacteria interfering. The algal cells were counted or quantified using a hemocytometer under a microscope. There's a little picture of me doing that here. And then on day 7, we measured photosynthetic activity. For our results, we observed a general kind of consistency in algal population growth for most of the concentrations between 0 or control group to 100 milligrams per liter. At 250 milligrams per liter, there was a pronounced increase on day 7 in algal population, and you can see that very clearly right here. So all of the other groups from 10 to 100 milligrams per liter had higher population counts than the control on day 7, but 250 milligrams per liter had the highest population count. The only replicate that ended up with a population count lower than the control on day 7 was that at 500 milligrams per liter. So that shows that there's some kind of promotion of growth happening at a little bit lower concentrations, and then at higher concentrations of polystyrene, there's inhibition of growth. Over here, there's some of our photosynthetic data, and these, so we can see generally that the control group is pretty stable with its efficiency values. We have effective quantum yield, maximum electron transport, and photosynthetic activity. So a higher value for these guys means they're more efficient, and a lower value means less efficient. So these are showing a general pattern, control group, and then as we increase in concentration, we go down in efficiency, and we can see that very sharp drop at the 250 milligrams per liter concentration. But then interestingly, at the 500 milligrams per liter concentration, we see a sharp rise and increase in photosynthetic activity or ability. The exact reason for why all these things are occurring is not really part of this study in particular, but we can theorize about that, and other studies have. And it's very interesting to learn about that. So things like aggregation of polystyrene and algae particles, things like that, or perhaps even the polystyrene kind of blocking the light from getting to the algae, so that could affect photosynthesis as well. There's a lot of different theories about why this might be happening, but this is what we saw for this experiment. So just in conclusion, we saw a pattern of decreased photosynthetic capability and either no change or increased algal growth after exposure to polystyrene from 10 to 250 milligrams for 7 days. And then algal growth inhibition and increased photosynthetic capability was observed at the 500 milligrams per liter polystyrene and after 7 days. So thank you so much, and please let me know if you have any questions over in the comments or on the Blackboard meeting next Tuesday.